All right. It's 8 o'clock here in Rome, and it is 6 o'clock in Ghana. So I guess we are ready to start. I see a lot of you have joined. We have more people joining. It's great. A couple of bots with us as usual. But yes, we welcome everyone. We are an inclusive group. And I like to go ahead and start, but before I start, um, I like to give new new people joining our call for the first time today the opportunity to just say hi and introduce themselves and just to quickly say something about your interest in AI and LP or something like that. Or if there's some cool project you have worked on, you can also mention it. So yeah, if today is your first time joining, I already know there's them, but probably there's another person or another a couple of people. You can definitely yes, take the floor and introduce yourself. So yes, I'm going to leave the floor open and go ahead and just take the floor.
Hello. So my name is Benjamin. This is my first time joining a meeting. Yes, uh, and my passion is really for reinforcement learning, but um, technology doesn't go so far on its own. It does so when things intersect, when different technologies meet. So that's what drives my passion for learning. And I'm happy to find a home here in NLP, in Ghana NLP. And currently, I'm trying to learn how to fine tune models to build one for the Ghana LLM project that we have. Thank
Awesome.
you.
Thank you, Benjamin. That's really great. And I'll be giving a big some overview of the Ghana LLM project. Yeah, something that we hope will really help a lot of us to be able to say that yes, we have trained a model, in a special Ghanaian language. So yeah, let me leave the floor open. Anyone else wants to take the floor? Okay, set them go ahead.
All right. Hi, everyone. Good evening. My name is Sedema Mediku, and I'm currently doing my master's in computer science at the University of Warwick in the UK. I did my undergrad at Chelsea University. I actually worked with Ghana NLP's models, including Abina AI and then the text to speech and speech to text and the translation model between Tree and English. I use it to create an AI powered mobile device for disabled individuals who speak Chi to be able to communicate with digital technologies like apps and without using their hands, without using limbs. And I actually joined the Ghana NLP community. Mr. also reaching out to me on LinkedIn, which I thought was like, it was very timely and nice since I worked with Ghana NLP tools. So I'm just here to learn more and to grow. And then this being my first time, it's actually been a stretch because I should have been here a while ago, but it's now that I'm joining, actually actively participating in the meetings. So I'm just happy to learn and willing to learn more from all of you.
Awesome, awesome. Thank you so much. And yeah, that sounds like a really cool project, Sedem. And if there's any way to, if it's shareable, if we can find out more, we have our Slack. Yeah. All right, all right. Bear home you later. Why? May a meeting. To my meeting. Why? Mhm. Yeah, I always have a second person in the call. Yes. See, bene. May a meeting, my menu. Yeah, you. Yeah. So, yeah, that is really great, and I see them give a thumbs up, and yeah, I think that's all what we are trying to achieve. Language is communication. Language is a fundamental human right, and language is inclusion. So this stuff we are trying to do, it sometimes seems that it is a um it is a something extra to have, but it's actually essential. When you think about people who without such technologies cannot participate in society, it's really it's better. Anyone else wants to take the floor to say hi?
Hey, good evening, everyone. My name is Franklin. I'm a first year student at the University of Ghana. I don't have much experience with AI. What I usually do is with software engineering, but I want to learn more about the field, which is why I'm here. So, if that's okay.
All right, that is awesome. Yes, and we are glad to have you here. And yes, and we are looking forward to, sharing and also learning from your own experience. Let me also see if there's a final person. Otherwise, I'm ready to go.
Hello.
Okay, I see Adams. Over to you, Adams.
Yeah, hello everyone. Yeah, my name is Adams. So I did my undergrad at KNUST, and I am currently running my own like small startup in Kumasi. It's an education startup. And with regards to AI, I've done a couple of projects. I also have a publicly available data sets on Kaggle. That's on like keyword spotting. Yeah, and I think primarily for me, I'm here to learn more about LLMs and see how I could integrate them in some of the solutions we are working on.
Okay. That's awesome. That's awesome. Please, if you can share that data set link, that would be great. Yeah, we'll be glad to explore it.
Yeah, I'll share
Uh,
it.
all right. Thank you. Yeah, so I guess we can't introduce everyone because of the time, but we are really grateful to those who have taken some time to, help us get to know them, and we keep the conversation going on the Slack channel. But I'd like to, at this point, welcome anyone who has just joined, and we can go straight into the main subject for this call. Let me share my screen. All right. I believe you can see my screen. This is the Ghana LM repo page. I wanted to start from here and kind of give you an overview of where this model that the model that I want to talk about today, where it fits into in terms of our community. So there's a lot of us, I believe, who are working already on models, trying to fine tune models, building from scratch. And I know there's also a couple of us who are still at the stage of exploring, and maybe you've not yet, run your first code to build a model. Um, and as a community, there is something that brings all of us together, and that is the interest we all have, right? So we all have the interest in AI, NLP, machine learning, deep learning, all of that. And sometimes it can be challenging to provide support when we have so many diverse, you know, uh, development environments, I would say. Let me put it that way. And when it comes to machine learning and training AI models, the complexity could come from the different models we are fine-tuning, right? Like someone is fine-tuning Quen, someone is fine-tuning Mistral, all sorts of, and that is great. And I think that is really helpful. But for this project, we wanted to see if we could all come together, find a specific base model that performs well when it comes to being fine-tuned for specific tasks, right? In local Ghanaian languages. and then be able to work around that model as a community to support each other, to build models, to fine-tune models on this base model. So that is the whole idea of this Ghana LLM. So that when you are trying to work on it and you hit an issue, you easily can get support because somebody else has run the notebook, somebody else is also using the same model. I think over time we can expand the list of base models we work with, but at this point we are looking at working with the Llama 3.21b. That one is one of the smallest and yet most effective models when it comes to multilingual capabilities. So we want to work with that for now, but over time we could have a couple of additional base models that we work from. But the key thing here is when you are trying to follow this, you are trying to work on training a model using the tools that we provide under this project, you are not going to be working on them in isolation. You are going to have the community support element, right? You can easily write to me, you can easily post in the Slack, and you can get support. That's the whole idea. So we have here a couple of notebooks. We have a notebook here where you can use to prepare data set, right? For fine-tuning the model, this base model that we have. And then we also have a notebook here where you can use to actually train the model. And that is what I'll really go through. I think I'll also take time to go through the data set as well. But that one is the boring part. But yes, I'll go through it. But we have these two notebooks. And if you follow them, it's a matter of opening them in Colab, running the code, and then you end up with your model. As simple as that. And it's not just about leaving you and saying, "Oh, go build your own data set. Go build your own data set, and then you need to use that to train your model." We are going to make available some data sets, right, that you can use. So we are putting together some nice quality data sets that are just plug and play. You basically just plug them into the notebook. You just specify the link, the Hugging Face link, and you are already ready to fine tune. So then it's up to you to just run the code and you end up with your model, right? And I think that hopefully from this project, a lot of us can move from the stage of maybe not having even trained a model to being able to train a model. And with that comes a lot of additional learning and being able to explore further. And for those of us who are more advanced, this is definitely an opportunity for you to also do more, because we all know that it's not just about fine-tuning models. There's a lot of things that go into building a production level. And when you see this project, there's a lot of, I've used one word, experiment, because I think LLMs, we are exploring them. There's so many things we can do with them. You are seeing here the coding, and what we'll talk about today is for a coding assistant, but it can be used for so many other things. And I think there's room for advanced users to still explore and see how well they can train models to be a production-ready model that, like we are all using now. We are all using ChatGPT and other large language models. Beyond being able to do something that works, can we do something that actually is reliable? And so all of this is what we are trying to do with this project. And with that said, I want to take us through the whole process and what I had to go through to put together this model that we want to talk about today. Maybe I should first demo the model. Let's go to the model demo. I've named the model. That's the beautiful thing about training your model. You get to name it. So that's what I named my model. Please don't judge me for the name I picked. I just came into my mind. I was thinking about Openi, like an elder, and I said, "Oh, let me just do Openi without the N," and then that will be the name of my model. So I call it Openi Coda 1B, as it's essentially a fine-tuned version of the llama-based model that I talked about. And I think one thing I didn't mention about the Ghana LLM project is the notebook we are offering is basically also very efficient. So the approach is such that you could even fine-tune the model without having to spend so much on GPU, right? Because when you normally want to fine-tune a 1 billion parameter model, the part of the reason why many people don't end up training the model is you have to spend a little. And we are using a particular library called Onslaught. I think some of us may already be using it. And Onslaught really makes it easy to kind of fine-tune models for a low resource usage. So with this model, I trained it for about 8 hours on a Google L4 GPU. So you could literally also train your own model with just about 16 hours on the Google Colab free T4 TPU, which is free, except it runs every 4 hours, it runs out. So you train, you save the checkpoint, you train again, 4 days, 5 days, you are done, your model is ready. So that's basically the approach I used for this. It was very hassle-free. But of course, it's not production ready yet. This is like a first stage. I trained it for just one epoch, just one. Let me just put something here. So essentially, the way it works is it can accept instructions in tree with code, or you can ask it a question about code, and it will respond. So for example, let's see, I have some example questions here, right? And I tell you in advance it's not perfect, but let's see what it says. This is an example question. Mayday a mature Python function. This is basically asking, how can I write a function in Python in tree? So let's see what it says. And what I like about this model while it responds is that if you use models like the Llama 1B, it's quite efficient. I'm actually hosting it here on a CPU. I'm not even using a GPU. So in terms of deployment, that kind of thing, it's also quite efficient to work on a base model that is not too large. Yes, even though the smaller it is, the more work needs to go into the fine tuning. So here we go. It says, "Ubetumi the code I did this we at Python Jumedi. Dev greet name, print hello, whatever. Side Jumedi, I the code is not the Python gurus. You can check if it's perfect, but I think for me, when training this model, the most important thing for me was for it to be able to do the explanations coherently, right? The explanations, these ones, ubetumi the code they did this way and this part. I didn't want any rambling. So I was very happy that with just one epoch, just a few hours, it could already pick up that language and actually understand and be able to respond in a coherent way that the user can understand. And yeah, I think part of the reason is maybe also coding. When you're looking at code, it's a universal language. So it's really probably helped for the code to be able to connect things better, since you are looking at it's like a mixture of tree and code. So it helped it to put things together well, because from what I know, you normally don't get the same results when you are training, just pure text, and the model has to learn everything in tree. So with this, we know that code already has functions, right? And I didn't translate that. So I'm going to go into how I prepared the data set. And that was the most critical thing. In fact, that took the most time in this whole process, figuring out how to translate code data sets into tree without breaking the codes that are in the data sets. That was the most challenging part of the whole process. And I will probably maybe go into that a little. So yeah, this is the model. Maybe we do one last test. Check near for loop. So yeah, for loop is like something in Python. Or yeah, let's just try that. Once we get the result, I'll just go ahead and we can go into the notebook. There we go. Or Python mono for loop or coin or fast ye loop I sign at the range be I taught was so yeah, so it seems to work. And the reason why I'm doing this demonstration is to show you that if you do go through the process, you could end up with something actually useful. Mine is not production ready. It's just it's very at the early stage, first stage, one epoch. And if you decided to train yours very extensively, you probably get better results, right? And it could be more ready for deployment for the specific use case you have. Yes. So that's essentially it. You can see it gives all the explanation and gives code examples and all that kind of thing. So yeah, where did all of this come from? Where did all of this come from? Let's go into the data set. I've really have a very strong kind of love for data, and it is where I think a lot of the magic happens when you are trying to train models, especially for our local languages where there isn't enough data. This is my Hugging Face repo. You can look from your Hugging Face. There's a couple of data sets there that can be useful. So this is the data that was used to train the model. Essentially, you have conversations, right? So you have conversations like this, a lot of examples of conversations where someone asks a question in Tree, and these were originally in English and they were translated to Tree. So someone asks a question and there's a response from the model. So based on the synthetic data that was used, it is a kind of conversation format data. So you have a question, you have a response. You have a question, you have a response. And there are 170, actually this data set actually, I have to update it, but there are 170K examples. So that means 170,000 rows. There are even more data set out there that have more. They have even more examples. So that if you wanted to train something that is very, very broad and people can access all sorts of things, then you can actually go for more data sets. Like this data set that was used, it is like kind of a mixed data set. It has some HTML, has some CSS, has some Python. A lot, there's more Python than others, but it has beyond that, it has Java, it has all sorts of questions. And so essentially, the 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 data determines the quality of the model, right? And that's why I was saying I really like the data side a lot, because if you are the kind of AI engineer who is relying on some data guy to always define your data for you, you don't always understand how your model behaves. You are always kind of figuring out whether it is your training approach or it is the data. But if you really take more control over the data, it helps you when you get your results. You're able to isolate and try to troubleshoot whether is this a result I'm getting from the data or is it from the training technique? And should I improve the technique or should I improve the data? Right? So I think it's very good, even if you want to focus on the AI engineering and the training part of things. And we do need a lot of good AI engineers who understand how to train things very efficiently for our context. But at the same time, it's always good to also have a strong understanding of the data side, such that you can, even if you don't prepare the data, you can really study the data you want to use and understand the shape, how the data works, right? To give you an example, let me just go back to this demo. Let me just put in this calculator example, because when I tried it, I got a response that is not necessarily perfect. So I want to try it with you here. You see something. This one says calculator programmer anything. Write a calculator program that is easy, a simple calculator program. So basically the code for a simple calculator program. Okay. Oh, interesting. Well, that's the thing with LLMs, right? You can't predict them. When I tried this model on my own, okay, now I get it. Actually, I did two training runs. When I did the first training run and I ran this code, it really gave me some confusing results. And I wanted to use that as a demonstration of how the data affects. But yeah, it gave me a good result. So I guess my point is not going to work. Anyway, so let's go to the main notebook, and then we can work from there. Yes. I'll come back later, I think, to the data to talk a bit more about placeholders. So yeah, this is the notebook we used. And this is when you go to the Ghana LLM repo, then you click the train model link. This is the notebook you are going to be taken to. And essentially, it's an Onslaught notebook. I really encourage you to check out Onslaught. Onslaught is a beautiful project. I really was glad to discover it, because a lot of times you want to try new things, but you don't want to spend a whole lot of GPU resources, right? This is the perfect, they give you free notebooks for fine-tuning, not just text models, but also text-to-speech models, speech-to-text models. You just need to figure out the data side. So if you can get your data, you can just plug into the notebooks and you're ready to go. So basically, we are borrowing an Onslaught notebook, and we are kind of using it for our own project, right? Using our own data. So yeah, this is the first cell you run, basically to install the requirements that need to be used for the training. So here you can see I've connected to my T4 notebook, Collab T4 GPU. And if you open this notebook automatically, it's going to be kind of set to use the T4 notebook. So you just click connect here, and then you are ready to go. So let's just run this cell. Essentially, this cell is just going to install all the requirements, like what Onslaught needs to work, that kind of thing. And then it gives us, all those essential libraries we need for the training. It's a pretty straightforward, yeah. Yeah, so you give it a while. Yeah, so while it runs, I can talk you through this part, right? This second code that we need to run in the notebook. So this is the cell where you set the model you want to train. So as you can see, I mentioned that Onslaught really kind of allows you to fine tune all sorts of, and they give you the option to even fine tune other models beyond this. But whenever you change the model, you have to also be wary of the architecture. So this is just an example notebooks. You cannot just switch without making sure that the codes that you run after us are all matching the model up here. So yeah, but you can see here the list of models that are available that you can fine tune. And in our case, we have set that to what? Llama 3.2. So this is where we've set the model. If you wanted to set another model, this is exactly where you do it, right? So you said that we are using Llama 3.2 Instruct that is hosted by Onslaught. Normally, this model will be hosted by Meta, which is the one that released the Llama model. I mean, Facebook. But Facebook's Llama is a gated model. Okay, just to explain to you, when you see that the model that we are using, the source of it is Onslaught, it's the same Llama 3.21b that Facebook released, but Facebook's own copy is a gated model. What do I mean by a gated model? You are going to have to request access to get access to it. So if I say Meta, yeah, this is the one, the original one. So basically what Onslaught has done is to just make a copy of it, right? So ideally we would have used this and then when you come into the code, you should see meter llama / llama, whatever. But because it's a gated model, it can be a bit more not straightforward. It means you have to, first of all, request access, be granted access to the model, and you have to set your Hugging Face token in the code before you can access that model. But by using this Onslaught version, the copy that Onslaught has, we can basically just put that here, the Onslaught one, and we are ready to go, right? So that's why you see we are using the Onslaught, but it is the full Llama 3.21b instruct. And this part is also important. Let me talk a bit about the flavors, right? So when you go out there and you are looking at the Llama models, there are different versions, right? And different versions also come in different kind of flavors. So there's Llama 2, Llama 3, Llama 4, but the Llama 3 has the 1B variant, which is the size of the model, the smallest, is the smallest. And with that one, they do have the base model. So you may see that there's another model out there which does not have the instruct suffix, right? It just has the Llama 3.21b only. It's different. It's not always the same. So the instruct is more fine-tuned for instructions, okay? When you pick the base model, you should be ready to also make sure that your training data has a very good, consistent instructions, because you are basically fine-tuning it not just to learn, to respond, you are training it also to learn instructions, right? But when you use the instruct model, it has already been fine-tuned on common instructions, right? Common commands. So with just a little data, you are able to make it pick up instructions, right? So that when you are done training and you are querying the model, you don't have an issue where the model knows it, but it's having a hard time corresponding the user input to the actual training input data. So yeah, that's why we went for the instruct version. But the base model is also very useful for other things, right? Like if you wanted to just train something which is more like a classification model, whatever, then you could go for the base model, which is not the instruct. The instruct is also more chatty. It's more for something where you need the model to be more generative, to be free to generate. So it's more for the things that are more chat style with some photos, that kind of thing. And the base model can be for things like, even if you want to fine tune it for translation tasks, the base model may be much, much, much better. Yeah, so with that said, yeah, I guess our first code has already completed in 52 seconds. Now we run this to set the base model. And just to be clear, I'm not going to go through the whole notebook. I'm not going to train a model here. It's not possible. But just to run the cells that are possible to run, and just so you also see how it works. So yeah, so basically Onslaught kind of does this. And let me just take this moment to also highlight something. I think whenever we use these libraries, these frameworks that are free of charge, it helps us to also think about building something which others can also use free of charge, right? And I always encourage that when you are thinking of training a model or doing something, please think about the open access, think about the open source, think about making it available if you can. And even if your result is not great, you have just done the first training, it just speaks very little. If you publish it, somebody else can build on it. I think it's very critical. We need a lot of that, where you can share what you have and others can also build on it. So yeah, this part is already done. Basically the model has been set, has been downloaded to our training environment. And then here is where they set the LoRa. I mentioned that you can actually participate in this project we are trying to do to train models faster, right? Because Normally, if you wanted to fine-tune a 1 billion parameter model the old way, you needed a lot of GPU. It's not 8 hours. It will take you maybe over 200 hours to train that model. But now you can do it more easier, right? So now you can basically train just a small percentage. So in this case, when we say LoRa, that means that low rank something something. But essentially, you're just training like a percentage of the larger model. In this case, you are training just 10% of the 1 billion parameters. So we are just fine-tuning my mathematics. We are fine-tuning 10% of 1 billion is 10 million, right? I think so. I could be mistaken. But yeah, you're essentially fine-tuning just 10 million parameters instead of fine-tuning 1 billion parameters. So this code does that. Let's just set that. Yeah, so it's good. These notebooks are made for us, but it's just good to know what you are running when you're running them. So if there's an issue, you know how to troubleshoot. And then here is where you set the data source, right? So as I said, we've already made some data sets available with a caveat. Data sets have been made available under a community access kind of agreement. And this is the agreement. You access those data sets by contributing to some of our existing projects, okay? It takes a lot of time to work on the data sets. So we want you to also kind of show some commitment to working on things that benefit others. So yeah, to access these data sets, before you try to do that and train your model, please go to our Insenku repo and see how you can contribute to that. It's very easy. Just run a notebook for about 3 hours and you can get a file you share with us to basically help us evaluate how LLMs perform on Ghanaian languages. And you can get access to not just this, there are 3 data sets for Ghanaian languages that you can use to train models. There is the one for Chi, there's the one for Ga, and there's the one for Ewe. So basically, if you wanted to use Ewe, the Ewe data set, you just change this to Ewe. If you wanted to use the Ga, change this to Ga, and you can have access to it, right? But you need to first you contribute to some of the work we are doing, and then you can also get access to the data. So yeah, basically that's how it works. You change this here to your data set. In case you have already prepared your data, then you can also use that. And we are using Hugging Face here. So what we put here is the dataset ID from Hugging Face, right? So if you go on Hugging Face now, you find that we have this dataset hosted there, and then you basically put that ID here. Let me just maybe go a bit into the Hugging Face of things so that I'm not rushing too much. Yeah, so here you go. As you can see, this is a Hugging Face dataset, right? And you come here, you copy the ID. You click on this copy link. You come into the notebook. You paste. And then if you have been granted access, it's going to be smooth. You can easily log in and use the data. Yes, so that's essentially how it works. And then you now move to the next step. Let's run this first. Hold on. I need to, okay. I'm going to use another data set because I have to fix some permission issues with this data. All right, so sorry. Let me try again to copy this data set. All right. So essentially, when you run the code here, it's going to download your data set and it's going to allow you to basically get ready to use that data set for the training, right? So the data has already been kind of formatted in the way that this particular notebook expects, so you can easily use that. So here we go. You come to the next code where you run this code here is basically standardizing the data set so that you can get the data set in the format that the training expects. Yeah. And then you have some follow-up codes here. They are not critical, but it's just to show you some of the elements of the data set. If you want to run it, you can run it. Other than that, you can also skip them, but it's just to show you. Like this one will show you the content of the fifth row in the data set. So here you go. Yeah, this is for another language. So yeah, in case you're wondering. Yeah, and this also shows you, it's basically showing you the reformatted data to be used for the training, but it's not critical. If you left them, you can still run the code. Okay, so here is very important part. So here is where you set the training parameters. Basically, you run this code and then you're ready to train, right? So when I ran this training, I did it on a Google L4 GPU, and that L4 GPU does have a RAM of like 22.5 gigabytes. For the Collab T4 free TPU, it has GPU, it has less. It has actually 16 gigabytes memory. So it's ideal to set this one to 8, right? Half. It could end up saying 8 is still too much, but I think 8 should work. So you set this here, the batch size. So the batch size is essentially how much data you're going to be pushing through when you are training, right? So how fast do you want the training to go? So if you set this to a very high number, of course the training goes faster, but you have to make sure that the GPU you are using supports that kind of speed, right? Essentially. So in this case, with the T4, we have to use a lower number. So there we go. And yeah, there's already some things we have set up here. For example, I've set it up such that it will store the training output inside your Google Drive. So it's important that you mount your Google Drive. You remember at the beginning, did we mount our Google Drive? Let me see, did I forget to do that? Okay, if we forgot, then I guess that's something I have to update this to add. It's important. So let's come here. Yeah, we do have this cell here. I'm going to move it up. I'm going to move it up to this. Right before you run the training script, you can mount your Google Drive. It's important because if you choose to run this and the directory here is not set to a Google Drive location, it will store, if your Google Drive is not mounted, it's going to store the training files right on your collab session. Okay, so it will store it in this session folder. The problem with the session folder is when your 4 hours has run out, you are not going to be able to get access. Everything there gets deleted. So essentially all your time goes away. So that's why it's good practice to always use the Google Drive to store your model outputs. And the outputs are not going to be huge, so don't worry about that. Because we are using the LoRa method, the outputs are quite manageable. So you can basically store it in Drive. Your Google Drive, you have about 10 GB. It can handle the outputs of this training. Yeah, so let me mount my Google Drive and then we run this. I want to kind of see how quick I get through this, and then if you have any questions, you can ask. I know that this is maybe, maybe even too fast or something, but we'll have the recording. You can take time and practice, and then if you have any issues, you can ask questions. So we help you out. Okay. All right. So now we've mounted our Google Drive, so we can store the model output. So I'm going to run this code. And I think something here I should also talk about is the number of trained epochs. Here is where we set how to the extent we want to train the model, right? So this one epoch is what took me about 8 hours on a higher RAM GPU. So if you are training on a T4, yeah, you can leave it here. If you have if you want to buy credits and you want to set it to a higher amount, you want better quality, you can definitely increase this. You can do like 3, 4 epochs and probably you have a very solid model. So yeah, around this. Sorry. Yeah, so it's going to do some tokenization here to prepare the data. So it's ready to be used for the training. Yeah, this is what I really love about this Onslaught notebooks. Everything has been set up for you. You don't have to do the work. And it kind of brings me to a point, like a lot of the AI training that we do now, eh, now like a lot of the frameworks are very easy to use. So if you are here and you are wondering that, oh, this is for technical people, like things are very different now. The tools that are out there are built for anyone to use, with a little help from ChatGPT to troubleshoot. You can literally run a lot of experiments. So, yeah, I'll encourage you if you are still trying to figure out if you are a technical person or not. You don't have to be technical to use this, to do these things. I'm not a developer. I don't call myself a developer, so yeah, but you can do this without being a developer. So there's no reason not to do it. And nowadays, having these skills is very useful for any career you have, right? Because it's all about productivity. And if in the office you can actually build a model to solve basic problems, then you are actually more useful to whatever career you have. So yeah, it's the age of AI, right? Yeah, I guess this one is taking a little bit of time. But I'm going to go in the chats and see if there are any questions in the chats, and then we could already start responding since time is. I see a question there. Someone is asking whether under the hood we are translating the chi prompt into English. Actually, no, Andrew. We are not actually doing that. So basically, the way we train this model, we trained it purely on chi, and it has actually learned to understand chi, and it is actually responding in chi. That is the cool thing I think about this model, is that we are not using translation. And I didn't even train it on like chi English, right? If you saw the data set we used, it was not like chi code to English code, right? So that we teach it what chi code means in English. No. We just trained it on chi question with a chi answer. And it's able to build on top of its own knowledge of English and its little knowledge of chi to kind of do all the magic. So it has that native understanding of chi. And I think that is a kind of pretty cool thing that these models are able to do. So yeah, that is essentially how it works. And let me see if there's any other question. I don't see any other question. But yeah, if you have one, you can also take the floor. Yeah, I see someone talking about the GPU issue. Yeah, it's really a matter of time. And I've noticed that with these models and with data, you need time. Okay. I've literally been working on some data sets, which will also be released as a community data set. But it's taking me like over 5 days. Some of them take me 10 days. So there's a lot of time needed. If you have time, you can do a lot. You run if you are willing to put in the time, even if you can buy all the credits, some of the stuff just need time. Like if you look at this translation, it takes time. And I couldn't get time to go through the data set process, but there's this library on GitHub which gives you unofficial access to free Google Translate. It's a popular library that I believe everybody uses, but you have to be nifty in how you use it. And there's some good code that you need to write to make it work well. So if you do that and you are willing to also wait, then you can actually get a good translated data set for anything that you want to do. All right, so now we go back to this. It's already done this part. And this part is just something I put there just to clear GPU RAM when it's too busy. So let me see. Yeah, this code is actually not necessary. So now we run this final code, which also essentially it's a new thing where they are saying that you don't need to train the model on inputs so much as outputs. It's complicated. I think maybe there's a paper out there that can explain it better. But running this code essentially does that with your data set, where it's telling the model to measure its progress not by the inputs but by the outputs. So that's what this code does. Yeah. And once that is done, we are ready to run the code for training. Yeah, so this is the code we use for training. If you are now running the training afresh, then you need a different command. This command you see here is for resuming training. So in case I'll leave both there. So when you start afresh, you run this first one, and when you are trying to resume after your credits have run out, then you can use the second one, right? So the first one here is what we'll use. Yeah, I think we need a whole session on the data set preparation, because if you figure out a data set, you can train a lot. And I have some very cool projects I'm working on, but it's all about getting the data. So if you can get the data, you can really train some really cool models. Yeah, so here we go. We can run this and the training should start if everything worked well. Okay, yeah. Yeah, so essentially this is where the time factor comes in, right? So you run this, you can see the GPU shooting up to 8.4, and you see the loading bar come up, then you know that you're kind of in business. Yeah, so it will start basically showing you the steps, right? So it's step one, step two, and it will just keep going and keep going, keep going. And ideally, if it's working well, you should see a downward trend, right? So it may jump up a bit, especially at the beginning, but you have to notice that at least it's going down. If it's not going down generally, then it means something is wrong. Probably either your training data is not good or something like that. But yeah, As you can see, at least it's started to show some signs of going down, but it needs time. So essentially this is it. And you could already be training your model, like you leave this, and if you're on a T4 GPU, you just leave this. If you set your outputs to the Google Drive, you leave it until your session runs out. And then when it runs out, you can reconnect. And when you are reconnecting, now you should use the resume, this second code to resume. And then since you've already set your outputs folder, it can use the latest checkpoint and use that for resuming. So you just keep resuming until you get to the point where you want. Or if you have credits, then I guess you just run this until you get to the point where you need to be. So that's the process I use to train my model. And we have very little time left, but let me see if there is any other questions. How do you go about putting together this? Do you rely on organic or synthetic data from other translation models? Absolutely, I do. I do rely on I don't know what organic means. I rely on free translation models out there. There's one I'm going to put in the chats. And I actually learned it from this community. Someone showed something in this community in one of our meetings, and I learned about this. I don't think I'm the only one that uses it in terms of the AI community, even outside of Ghana. It's not, let me just, in the end, it is Google Translate, but it is basically a kind of a reverse engineered API from the free Google Translate that is available, right? So like what you can use in the web. So when you use this, it's essentially as if you are using the web, but without going to the web to put in the translations. And there's someone who has put this library together. It's very helpful. It depends on what you are doing. For this coding data set, NLLB was not helpful. The Facebook NLLB is also a very useful model, and I use that also for some of my translations. But for the code, it was really getting confused. So I kind of used Google because Google knows how to just leave the entities alone, right? So things like Python, it doesn't have to touch it. Otherwise, if you use a model like NLLB, Python, the word Python may be changed to O, right? So you may have a challenge when it's translating everything like literally. So yeah, that's why I used it. Someone is asking, does it mean that the Llama model was originally trained on Chiga Ewe? Actually, I tested it. The way I tested to see whether Llama is good for this is I asked Llama, the model, I asked it to tell me a story in Chi. And when I asked it, it did not give me like a perfect answer, but the answer it gave me had some words that sounded like Chi in it. That was enough for me. You can test that on other small models. Like if you test it on the Google Gemma 1B model, you're going to find that it will respond in purely English. So if you get that kind of base model, then you're in trouble because it literally doesn't even know that tree is like, it doesn't know any tree. So it just knows English. So yeah, Quen is also a very strong model. Like the Quen models from Alibaba, they also are trained on multilingual training data. So even though they are not said to be like experts in these languages, they have been exposed one way or the other to them. And so we are able to just build on that and just fine tune it, and it can understand. So yeah, basically it can also do for other languages as well. If you had data for say in Zima or for Dagbani or for other languages, I believe that this model can also work well on those as well if you have data to train on those. Yeah. I guess yeah, the data set I've already responded to that, and there's the library in the chats. But there's a whole notebook on the dataset preparation. The key thing was to replace the code with placeholders. Very critical because you didn't want the translator to translate the code functions and break the code. So first I had to prepare the data and replace all the inline code and the block code elements with placeholders, and then translate that, so that when I translate that, I'm able to replace the placeholders back with the code. That was the most difficult part. I spent a lot of time because it was, the first thing was to figure out what placeholder should I use, because essentially Google Translate will translate anything, right? So you had to figure out what kind of placeholder would it leave alone. And I'm going to put that placeholder in the chat. If you want to translate stuff and you don't want the translators to mess with it, and I don't think it's just for Google, it's for many other things, you put them in anchor brackets. So you put your text in these anchor brackets, and then they will leave them alone. They will leave them in place, right? So that when you are done, you can replace them back. And this can be very critical, not just for this kind of thing, but if you are working on, say, a data set for translating domain-specific data with technical terminologies, you want to be able to have your model ignore certain terminologies. So you want to put placeholders, maybe numbered placeholders, and be able to replace them back with your own translated versions of those technical entities. You need something that your translation models can ignore. Google works with this, but other models, you have to test it some more. But that was really the most difficult part, because I kept using different things and they were all being translated. Yeah, but yeah, essentially that is it. And if you try the notebook for data prep, you have issues, reach out and we can help. That's the whole idea of this Ghana LLM. We can all help each other and everybody benefits. So with that said, I want to thank you so much for joining this call. Really appreciate your time, and we look forward to having you join our meetings. And yeah, stay in touch. Have a great rest of the day. All right, ciao.